So quick introduction, I'm Andrew. I'm co-founder of a company called LastMile AI. And our product is called MCP-Agent. It's an open source product, and I'm here to talk about it. I like free-form talks, and so you'll see that it is going to be just random, switching back and forth. I hope that's okay with folks. If people have questions, just let me know whenever, because I'm always happy to answer it. And so we can begin. First thing I'd like to get a sense of is, I couldn't get a sense from the talks how many people have already built and deployed an MCP server, or I guess hands up if you have deployed an MCP server. Okay. A lot of them are the speakers, so I might disregard that. How many people have connected to a client? Yeah, okay. Are we like Cursor or Claude Desktop? So coding agents or coding IDEs or Claude Desktop?
Claude Desktop.
Oh, okay, a lot of Claude Desktop. Okay, that's great. Amazing. Okay, this is perfect. I kind of have a sense of where to begin. A little bit of history of MCP-Agent. It was not what we were originally building about, 8-9 months ago. It was a project that happened on the side. We typically sold to enterprises, and I think for all the people who work at big companies, during Christmas time, nothing happens at a big company, especially in finance companies here, nothing happens. And so my co-founder was like, oh, there's a blog post that came out about MCP. It sounds really interesting. I think I'm just going to build an agent framework because it'd be really nice if agents could also be connected to as MCP servers. And we open sourced it, and we just kind of let it be. And without us really investing anything or trying to push it, it was growing quite a lot. And it was primarily from the fact of a few things. So it got to about, I think, 5,000 stars at that point. And the things that people really liked about it were really simple, and things I want to share with everyone, which is agent frameworks got fairly complex very fast. And so people who are using LangGraph, all these other agent frameworks, you're finding that they have everything supported in the library, but oftentimes 80–90% are not things that you actually need. And the complexity actually makes it even harder to debug. And then you're looking for debugging tools. And they happen to have a debugging tool they're selling to you. And so it's all kind of part of that play. And from our standpoint, it's like, it doesn't need to be that complex. There's this augmented LLM where for an agent, it should be able to call an LLM. There is the parallel workflows, which is it should be able to call multiple LLMs and aggregate the results together. There needs to be an orchestrator workflow. I'll show a quick demo of pushing the orchestrator workflow to the extreme end. And that's pretty much it. And everything else is these are the core primitives of when you think about Claude Code, when you think about OpenAI's deep research, they're built off of these primitives. Both of these companies release blog posts about building effective agents, and it's remarkably simple. And I think if you find yourself building extremely complex agents, there's a really solid chance that you're going down a bad path. It is remarkably simple to build some of the most powerful applications that are out there today. I think this is a good time to kind of at least show a quick demo of how far it could be pushed. So let me, also, can people see in the back? I was sitting in the back and I was like, I cannot see a single thing. And so I was like, once I get up there, I'm gonna try my absolute best so that people in the back can see, but I just realized it's almost impossible to tell from here. So, can people see? Kind of? Okay, I got the thumbs up from the guy who sat next to me. Okay, so a little bit about this app. We built in our framework what's called a deep orchestrator, and we were fascinated by the idea of these coding agents as well as OpenAI's deep research. How does it actually work? So who uses Claude Code? Okay, so when you're using Claude Code, the first thing that you see is that plan that pops up, and it's like, here's what I'm going to do. And you can escape to interrupt, and you could be like, hey, don't do that, or yeah, it looks good, go ahead, and it tries to execute. And as it's executing, it can occasionally have times where it's like, oh, I don't think this is right, so I'm going to try to redo this. Or it'll be like, I'm going to run the code, I'll see what the errors are, and then I'll refine it. That's called a kind of a deep orchestrator architecture. And what we wanted to do was we wanted to build it for a deep research into finance. Because something that comes up quite often, especially in New York, I don't know how many folks are working at banks or anything, but there's a lot of times you're looking for a lot of data, and analysts are going out to find data. And so one thing that we wanted to do was, what does it look like to reapply this architecture into a deep research workflow where it will go out, it will build a plan. So right now what it's doing is it's actually calling OpenAI's reasoning model to build a good plan. And this is how it starts off. Just want to make sure I have internet, right? Okay. So it's going out to create a plan. Give it a few seconds, I hope. I have internet, right? I just want to double check. And I'm not on a VPN, right?
We will leave you though.
No. I cannot be the fifth failed demo today. No, I have to power through it.
I just on the slides.
Is it the internet? Well, I tested it just before coming up too. Let's give it a second. Maybe it's, let me see. Let me run it. I do have internet. Let me just double check. Looks like I have internet. Okay. Let's give it a second.
Got a backup video?
I do have video, but
It's not as fun.
yeah, that's like, it's kind of lame. So I can do the video, but so this is part of the AI Alliance. It's the one. Oh, did it do something? No, it didn't. Okay, it just like kind of faked me out. So this is the AI in finance example, which is IBM and Facebook created this AI Alliance for open source technologies, and we're part of the alliance. And this was part of the app that we're all building together, which is a lot of fun. And this is the actual app. It's the same thing. I wanted to just show it live, but let me just double check. Still nothing. Yeah, what? Is the internet? Okay. And this is a video of the app running. And I can explain it a bit as it runs. So what happens is it will go and create the plans, similar to exactly how Claude Code operates. And so it will execute, it builds out the plans, and the plan is a standard first in, first out plan. It's a queue system, and that queue system is basically how it tracks the different types of things it needs to do to execute. For here, it includes gathering quarterly earnings, analyzing the last two earnings reports, collecting financial news and analysis. And as it executes, what it does is it has two important steps. One is it does a reflection of, is this the right step that I executed? And the second is evaluation of, based off of the information I got, did I successfully complete this task? And this is a really powerful architecture because when you run this in a loop and you run it across many, many different LLM calls with access to search, you're going to find yourself getting extremely promising results through this deep research. Our intuition, which I think is quite similar to a lot of other companies, is that this architecture could be extended not just from coding and search to a lot of other complex tasks. And I think, I don't know if people are thinking about building these out, but you should, oh, okay, there was a hand raise.
I was thinking about for recruiting. I'm in recruiting, so like this is really good, like going task by task.
Yeah. And it's great because most of the things that we do as people are quite complex, the tasks. And being able to break down the task into atomic units that an LLM can execute is really quite nice. And also being able to allow human interruption so that there's a task that you need to do, that you can do it, and you can let the LLM continue, is a beautiful architecture to basically use the power of the LLMs to really assist in ways that it can be done. Let me just double check on this. Oh, it did run.
Yeah.
But no one saw it. This is like, well, believe me, it ran. Yeah. So it's been running. Really nice things is budget management. These can be very expensive. It is accessing the full internet, fetching tons of information, especially financial data. It's quite large, and so it can consume a lot of tokens. The other really important thing is memory management. When you search the entire internet, you can't actually feed the entire internet to the model. So you need to be very judicial in exactly what information you pass in and what you want to pass in for it to work. And so it's really critical that, let's say for your hiring deep orchestrator, what are the key pieces of information I want to pass down from one step to the next, as opposed to feed everything. Because you feed everything, you're going to essentially run with tons of data, most of it not needed, and the actual result will be quite poor. So this is as far as the deep orchestrator goes in state of the art today. And so let me hop right back. Let's stop this. Hop back.
Do you know how many tokens you just burned in this little demo?
Oh yeah, it was like 90,000. But it was for the demo, even though I only showed the video. It was worth it. So for MCP-Agent, the key insight that we had is basically we thought that MCP would be everywhere. There was a blog post, open source, libraries out there, and my co-founder, Sir Maud, he used to be on the LSP team at Microsoft, where they built VS Code, Visual Studio, all that. And he was like, this is going to be pretty big. It's basically defining the protocol for these LLMs to interact with the world. And having that fundamental belief, pairing that with this, which was agents should be MCP servers. How many people know about A2A, ACP, some other acronym out there? A few hands? Yeah. So there's other protocols out there for agents. It's just that we don't feel like there actually needs to be one outside of MCP. MCP is robust and it is flexible enough that it can cover agents. Agents don't actually need to be a separate protocol that lives on top of it. And we think that this belief is true, and we kind of see the signs for it as well. A2A was donated to the Linux Foundation from Google, and so you can kind of see the signs that they don't want as much control of it going forward as well. And we think that it's probably going to happen that way. So one thing that comes up is, what does it look like to have an agent as an MCP server? And let me show some code. Where is, here we go. Okay. So this is using our library. It's a quick app I built in the time that we were having this. Let me zoom in. Basically, I just wanted to build a simple MCP agent app where I can just ask it questions about MCP agent and it'll respond with it. So just give it a bunch of information about it, let it access the internet, let it access our docs, just like give it any information it can. And the biggest thing with us and MCP agent is I define this MCP app, and then I just have the @app.tool. There are a few hands that said that they built MCP servers before. They should look familiar, right? Fast MCP, yeah. Basically, we just have the decorator. It is fast MCP compatible. It's just app.tool. And basically, this app.tool allows me to connect and have these as tool calls from any MCP server. And I could just run this locally, but locally is not as much fun as running it in the cloud. And so we will test my luck twice to see what happens. So right before I actually deployed it in, it's this simple command right over, sorry, it's right over, I can't even see it. This command, sorry. this here, which is it's just MCP-Agent deploy with the name of my app. And basically that deploys to our cloud platform. Building and deploying an MCP-Agent app into the cloud is quite interesting because we're kind of following the suit of having these micro VMs, Dockerized containers for each MCP server, as well as the full agent. And when I deploy this, do this, what it'll do is it will bundle the entire application together, and it will also put all the secrets I have, which are typically in a YAML file, into a secret store, and it'll deploy it into our cloud platform. And with that, I can actually connect it as a remote SSE server, MCP server, to any MCP client. And so let me go over here and show you all the MCP servers I connect to. There's quite a lot. And this is, so I deployed it right before. This was the presenter MCP server. And with that presenter, I could be like, it's a good one. Use presenter and get me information about, or tell me what is MCP-Agent. So what we'll do is we'll actually use this tool call. That's fine. That's another server. I have lots of servers, so don't worry. It's making a search. 1 second. Use the presenter MCP server. Okay, it's refusing to use the server. It's there, right? Oh no, it's off right now. Wait a second. Maybe it's because I'm redeploying it. Let me just double check. Just see the tool calls. Okay, let's try one more time. I forgot the query. What is MCP-Agent? Use the presenter, MCP server. Okay, so now it's making a call into the remote MCP server with what is MCP-Agent. And then it is, within the cloud, actually collecting information about MCP-Agent based off docs. And so I can actually go into, show you the config file. So this is, here it is, yeah. So this is the MCP, the hosted MCP server, MCP-Agent server. We basically put in a unique ID for it. We deploy it onto our cloud platform. You can access it through a bearer token for authorization, and then you pass in your bearer token. And this is how you could connect, which means I can actually connect from any device, any MCP client. This is really nice for companies that are have many different MCP clients within the organization because you can connect to it from anywhere. And then let's go back to Claude, amazing, let's see. So basically the response that came from this remote MCP server is MCP-Agent is a lightweight Python framework for building AI agents, blah, blah. And it kind of elaborates what the core purpose is. I think something more interesting is probably like who are significant contributors to the repo. And the nice thing about it is the tool call is very generic. I just basically said, get me info about MCP-Agent. Here's the MCP servers, file system, fetch. That's pretty much it, which means I can just interact with it as if it's an agent that has access to all this information. And it can just fetch whatever it needs, give me the information back. And so I can just interact it that way, which is quite nice. And then the other thing, how much time do I have? Am I okay?
Like 5 minutes.
Okay, 5 minutes, okay. The other thing I wanted to show was the actual, so this is backed by Temporal. Let me, oh, I shouldn't have done that. Oh, it's fine. It's backed by temporal, which is really nice. So when you're running a tool call, it's actually scheduling a temporal job and running it as a workflow. This is extremely different from how other deployed and hosted MCP servers are. And the reason why it's so different is we basically believe that when you kick off these agentic runs, these tool calls, they are long running. We believe that if it fails, that it should continue running, that you can pause it, you can resume. If it needs your input on something, it should pause itself, ask you for the input, and then it can continue running. And so it is all hosted on temporal, and you can actually use the open source and connect to temporal, or this is our backend where we connect it to our own temporal instance so that you can have it running. And then, let's see, I have just a bunch of things open. Let's go back here. And yeah, so MCP servers. So this is really nice because now that it's exposed as an MCP server, it doesn't just mean that you need to connect it to clients. You can actually connect it to other applications that connect to MCP servers. So these become more like fundamental building blocks for creating more complex logic. I know I just said that, but one thing I do recommend is still keep it simple. Because the more complex it gets, it is quite difficult to manage. The number of tools you expose, the number of different MCP servers you connect to, it all leads to a lot of complexity. When you think about things like Claude Code, and it has access to your file system, it has access to fetch from the internet, it has access to run bash, terminal commands, and it has its own memory. It's like a really small suite of things that are so powerful. It's like, it has 4 of these things, yet it is one of the most impactful applications out there, right? And it means that you can find really powerful multi-purpose MCP servers, connect them to create really powerful experiences, and you should view it that way as opposed to very, very specific functions that you hope that it can use, because then it becomes overly complex. Then all of your doc strings for all your tools, your MCP servers need to be perfect. The LLMs need to figure out exactly what it needs to do, which is quite difficult. Cool. And so with all of that, I think I just kind of leave it at a link to mcp-agent.com, the QR code. Check it out, build an MCP agent server, deploy it. It's free, so you can just deploy your own servers. We have some nice ones that go and scrape from our GitHub repos, give us little status updates of what are things that we're missing. You can create a nice one for sales. Like we just looked at the HubSpot MCP server, connecting that for like sales calls and stuff. And so yeah, deploy MCP servers. And then, oh man, I wish I labeled this QR code. I think that's our Discord. It's a Discord or somewhere. Someone will have to let me know where it goes. I think it's our Discord. A Discord, okay? Thank goodness, yeah, Discord. So join our Discord. We have a big community of MCP agent developers who are talking about how to combine these technologies. Thank you so much. Any questions? No questions? Okay, thank you so much.